Good morning. We have solved the problem like this where the source neutral and the load neutral were connected, and we had to calculate the line currents and the neutral current and the power delivered by the three sources. The results are here. So we calculated current I1 by dividing here. Remember the voltages here, the source voltages and the load voltages are equal. So we obtained the current I1 of 44, I2 of 22, I3 44, and we calculated the power of each source delivered to the load and the total power of this source. We calculated the neutral current. We draw the diagram, vector diagram of the currents here to show you how it looks. And now we are going to disconnect the neutral here, and we repeat the same calculations, the line currents, the power delivered by the source, and the voltage Vn n prime, which is here. So we can write that Vn n prime plus V1 n is equal to V1 n prime, and what we have to calculate in this one, Vn n prime will be equal to V1 n prime minus V1 n. V1 n prime, this is Z1 times I1 minus V1, which is the reference voltage, which is equal to 220 and 0 degree. Okay, this is for later calculations, and now we have to calculate the line currents. We have one node here. We can write that the sum of the currents is 0, and we have two meshes here, two meshes. So it means we can write that U12 plus Z2I2 is equal to Z1I1, and U23 plus Z3I3 is equal to Z2I2. Now we have a relation between the line voltages and phase voltages. There is a rotation of 30 degrees and square root of 3. So if you have to calculate U12, it's square root of 3, 30 degrees, V1, and U23 is square root of 3, 30 degrees of V2, and U31 is square root of 3 plus 30 degrees of V3. Remember that V1 is the reference, it's V 0 degrees, V2 is V minus 120 degrees in volts, of course, and V3 is V plus 120 degrees volts. And we see that here we have square root of 3 of V, square root of 3 of V, square root of 3 of V, and the argument is 0 plus 30 degrees, 30 degrees, minus 120 plus 30 degrees, it's minus 90 degrees, and here 150 degrees. So now we can solve this system of equations. We can change it a little bit. we have to replace I3 by minus I1 plus I2, and these equations will become and here minus Z3I3, and I3 we replace it by minus, it will be plus I1 plus I3 plus I2, and here we will have Z2 plus Z3, Z2 plus Z2 plus Z3, and here we will have Z3 I1. Is that right? No. Okay, so we have a system of equations that we can solve this way. So I1 will be, we use the determinant divided by this, and this one divided by this will give us I2. U12 times Z2 plus Z3 plus Z2 U23, Z1 times Z2 plus Z3. The results are here. We divided this by this, they give us 28.93 and argument minus 48.72. And here 25.72 and the argument minus 45.94, and then we can calculate I3. I3 is minus I1 plus I2 is equal to minus 28.93 minus 48.72 plus 25.72 minus 45.94, and this will give us minus this times cosine this 19.1 minus j sine of 48 21.74 plus 17.884 minus j 18.48, and the result is minus 36.98 minus j 40.22, and the result is in polar form 54.64 and 132.6 degrees. Now we can calculate the power delivered by the source, so we can calculate it here. We have S1 is equal to V1 times the conjugate I1 conjugate, S2 V2 times I2 conjugate, S3 is V3 I3 conjugate. I3 was calculated and it's 54.64 and 132.6 in amps. Okay, so 220 0 degrees V1, 220 minus 120 degrees, 220 plus 120 degrees times I1, the conjugate, plus 48.72. Here it's 25.72, plus 45.94, and here 54.64, and minus 132.6. And the result is given here. So the result is 6,364.6. Here it's 58.4, and here is 12,000.8, and the argument is 48.72. Here is this plus this is minus 74 degrees, and here this plus this will give us minus 12.6. So S1, P1 will be 4,099 plus J4783. This is P1, this is Q1, S2 is equal to 1,554.444 minus J 5,440.7. This is P2, this is Q2, S3 is 11,731.3 minus J 2,622.25. This is P3, this is Q3, and the sum of the three is P and Q here. So it means that is 17,484.74 and minus J 328. And that's it. This is in watts and these are in bars. We're left now to calculate VNN prime. I said that VNN prime is equal to V1N prime minus V1N. As I said, V1N prime is Z1 times I1. Z1 is 553.13 times I1, 28.93 and minus 48.72. That will give us a voltage of 144.65, argument minus plus 4.41 in volts, and here we can calculate VNN prime is equal to VNN prime is equal to 144.65, 4.41 minus 220 0 degrees will give us this times cosine will give us 144.22 plus J sine, this times sine will give us 11.12 minus 220, so we're left with minus 75.78 plus J 11.12, and in polar form is 76.559, and argument 171.65 degrees. And if we have to draw the vector diagram, I will try to draw it. If we draw V1 like this, I1 is minus 48, about this much, I1, I2 is a little bit less, minus 45. This is I1, I2, I3 is 132 and 54. It's about this much. This is I3 and IN, VNN prime, 76, 176, so it means about 1/3. This is VNN prime, and VN prime N will be about here. And that's it. And thank you very much.